Hi, class. I'm sorry to be a couple minutes late here. Looks like, all right. So I'm going to start with a 1-minute meditation like I usually do. If you don't mind, please get comfortable and prepare to meditate for 1 minute starting now. Okay, that's 1 minute. All right. Welcome to another Tuesday, another week of research methods in psychology. Do you have any thoughts or comments or questions you'd like to start with today? If not, let's go straight to lecture. All right. There's no quiz today, like I said. Next week there could be. What's an experiment? The topic of today is the experimental method or experimental research design. When we're doing experiments, we have to have an independent variable and a dependent variable. So you need to know what those are. Manipulate conditions. That's the independent variable. It's a manipulation. It's like giving treatment to this group and not that group. This participant, but not that participant. And the treatment doesn't need to be a therapy necessarily. It could be something harmful potentially. So just because you're in the treatment group doesn't mean that you're going to get some benefit. It could be a challenge against your ability, something to limit or something to strengthen, depending on your research design. Any questions or comments? Just chime in if you want. So next there's control or confounding, control of confounding and extraneous variables. The word confounding means confusing. We don't want to be confused about where is the effect coming from. Is it coming from variable A, or is it one of the confounding or confusing variables that I accidentally did not control in my experiment? Extraneous variables are anything that you're not interested in. They're extra, as the word implies. Something like room temperature is usually an extraneous variable because you're usually not trying to investigate the effect of the room temperature on performance on a test of some sort. So that's an extraneous variable usually. So is whether people are wearing their shoes while they take the experiment or not. Everyone should do the same thing. Otherwise, it's an extraneous variable. If some people do, some people don't. What about things like eating breakfast? It's an extraneous variable. Some people do it, some people don't. And that extra variable could influence performance. So there's all kinds of extraneous variables. And these can become confounding variables, which are variables that confuse your results if they are big, or yeah, I would say so. So big extraneous variables become confounding variables if they have some large impact on performance. Random assignment. We have to randomly assign people to conditions. If it's not random, then the criteria by which you assign people to conditions could be the cause of their performance difference. If I assign all the right-handed people to group A, all the left-handers to group B, and I give them some test, and I manipulate the condition, such as having them participate in a light setting versus a dark setting, well, if I don't randomly assign, if I group them by their handedness, that's not random assignment. So the grouping by becomes a variable. Do you understand? Does that make sense?
Yep.
Great. Between subjects variables or designs, that's one way to design an experiment. Or you could do within subjects designs. When I talk about left-handers and right-handers, that's a between subjects design. Because the light, let's say I'm giving a test in the light versus a test in the dark. The design is between subjects because I have two groups of people. One group does one thing, another group does another thing. Between them, they do all of the conditions, but they do it half and half. Half of them do this, half do that. So they're split. They're split up into different groups. The within subjects design is all conditions occur within subjects, within all of the subjects. If I'm going to do a light versus dark testing condition within subjects, first I'll do the light, then the dark, or the dark, then the light. And I could do different orders for different participants. But if everyone does both conditions, then it's within subjects. If some people do one condition only, it's between subjects. So, which kind of design would we use if I wanted participants to take a test standing up and take a test sitting down? Would that be a within or between design? if I want my participants to sit while they take a test and to stand up while they take
Is
a
it within subjects?
yes, yes. Within. And if you're thinking, well, this is a problem, you can't take the same test twice because of the practice effect. Yes, you're right. So it would need to be a similar test, a related test, but not the exact same test. Otherwise, there would be a practice effect. So we don't do within subject design if there's a strong practice effect, because the practice effect interferes with the within subjects design. So we use within subjects design when we can bypass or somehow overcome the practice effect. For example, let's say I have 2 IQ tests, and I want to see if people do IQ tests better standing up or sitting down. So I give the test to everyone. Let's say I give the test to all of the students in my class, 70 students. And I give the test one IQ test sitting, one IQ test standing, then that's a within subjects design. Okay, and then last thing here on the slide is the dependent variable. That's what you measure. If I'm giving an IQ test, it's IQ. If I'm giving a speed test, it's the speed of performance or the reaction time. Any questions? All right. So that's the basics of the experiment, the experimental approach. All right, so I started talking about the order effect, what I called the practice effect. This could also be called the carryover effect, the fatigue effect, or the context effect. Anything that impacts performance on the second test or later performance, that's an order effect if you're affecting this subsequent performance. All right, so the problem is the order effect. How do we overcome the problem? Well, we can possibly partially overcome the order effect by counterbalancing participation in conditions by assigning the orders in different orders to different people. If I have 2 conditions, the sitting and the standing conditions, how many possible orders are there? I could assign A and then B, or B and then A. So there are 2 possible orders, AB, BA. There are 2 possible orders. How about with 3 conditions? How many possible orders are there? If people do all 3 conditions, they could do ABC, ACB, BAC, BCA, CAB, CBA. There are 6 possible conditions. And the rule is there's X exclamation point or X factorial in mathematical language. That's how many possible orders of conditions there are. 3 times 2 times 1 is 6. How many possible condition orders are there if you have 4 conditions?
24.
24 is correct. Very good. And for the math expert out there, who can tell me how many possible orders of conditions for 5 conditions? Totally within subjects.
120?
Correct. Very good. So if you have 120 participants in a 5-condition within subject design, you can assign every single participant to a different order of participation in the 5 conditions. However, in practice, when there's so many possible orders, then researchers tend to either randomly assign people to random orders, or they do a very fully balanced one order for one participant like that. To exhaust all possible orders. But really the point is simple. Just to control the effect of practicing of previous conditions, to control how much they influence participation in later conditions. So we don't want condition D, to always be affected by condition C just before it. So we would want D to come right after C or B or A, and the frequency of preceding and following conditions should be roughly balanced or equal, or not too heavily this or that. Any questions? Okay, this slide is to guide us to deciding whether we want to use a within subject design or a between subjects design. And the answer is, if practice is going to be a problem, then you should use a between subjects design. If there's some effect of participating in one condition that influences you, changes how you participate in the second condition or the third condition, that's a problem. If it's a big problem, then you need to go with a between subject design. If it's a small problem, you can counteract that problem by balancing that problematic order with other possible orders of participation. ABC, CBA, ACB, etc. Otherwise, by using a within subjects design, you can test fewer people and you can better control other sources of error variance, which gives you greater power. Power in a statistical sense is the ability to detect an effect if there is an effect. Let me give an example. If you take tests better with the windows open in the classroom to let fresh air in, but let's say that the effect of windows open is very small. It's a very small effect. So you need a lot of power to detect that effect. Now you can get power very easily in 2 ways. One way to get power is to test a lot of people. Let's say you test 30 people, but you don't have any effect. You don't see any effect. Let's say you take 15 people and test them in a Windows open room and another 15 people in a Windows closed room, and there's no effect because the effect is small and you can't find it. You can't detect it statistically from your measurements. Okay, so how can we increase the power to detect the effect that you know is there? So you know it's there, you know from maybe from past research or because you know how the brain works, you have a really good idea that there's supposed to be an effect. But you can't find it because you didn't test very many people. So how can you increase your power? The number one easiest, simplest way is to test more people. So instead of 15 people per group, you could test 100 people per group. 100 with the windows open, 100 with the windows closed. Then you could probably find an effect. But there's another way. Let's say you're limited to only 100 people because there's only 100 people in the classroom. So you could increase your power. You don't have to have 200 people. You could take the 100 and you could test them in one condition and then in the other condition. By testing them 2 times, you're effectively gathering 200 participants worth of data. What's even better is those 200 participants, half of them are perfect controls for the other half. And I say they are perfect controls because they are equivalent. Okay, maybe I'm going a little too fast or getting ahead of myself. Let me go back and slow down a little bit. If I test only one person and I test them in the windows open condition first, and then the windows closed condition second, I have now gathered data from 2 participants, even though it's really 1 participant. But I have gathered data from 2 conditions, 2 data gatherings. And if I count each data gathering like as if it's a participant, then it looks like I have 2 participants. But the second participant is really the first participant participating again. By having them participate twice, all of the extraneous variables like their personality, their hunger level, their nationality, many
Um,
things. Yeah.
so overall, is it better to use a within subjects if you can?
Yes, exactly. It's better to use within subjects if you can.
Okay.
Exactly. It's more economical. You don't have to go recruiting more. You don't have to go paying people more or incentivizing them more because you've already got them.
But what if they change their minds during, if you're making them do, if you change up the experiment, would some of them leave because they don't like the new additions, like they're doing it again or something like that? Is there a
Yes.
possibility for them to leave?
Yes. Yes. If they leave halfway through this study, then you have shifted from a within subject design to a between subject design. Or you just lost a participant and you cannot analyze their data because their data has to be matched up with their own data in a within subject design. If they only participate in one condition and not the other one, then you cannot use that participant's data because you cannot compare their data to their data. So in a within subject design, you must always have every participant participate in every condition. And as I was saying, when that happens, when you get that, then every participant acts as their own control condition because they participate in the control condition and in the experimental condition. And while they're controlling the treatment in the control condition, they're also controlling a lot of extraneous variables like their traits, their personality, their nationality, all of the things that you're not really interested in. They act as the control for themselves so that their nationality does not influence their performance. It doesn't influence the comparison of their performance between condition A and B. It's not like one person can do condition A and then condition B, they're influenced by their nationality. No, if their nationality influenced one condition, it influenced the other as well. And that influence would be equal between the two conditions. So if nationality has some effect, it's canceled out by subtraction of the two conditions from each other. So within subjects, design is especially powerful because it can also control extraneous variables of the participants themselves. Does that make sense? Or do you have any questions about that?
No, it makes sense.
Cool, great. The next topic is validity. Here are 4 kinds of validities: construct validity, internal validity, external validity, and statistical validity. Construct validity is whether or not your construct, which is your experimental design, if that construct is valid or not. So to judge whether your construct or your design is valid or not, we ask, does it answer exactly the question that you had for your research question? For example, does wheat cause my dog to have allergies? The design would need to include a wheat condition and a non-wheat condition. Otherwise, there's a problem with the construct validity. If I tested 2 dog foods that both of them did not have any wheat, obviously there's a construct validity issue because I'm not answering the question of wheat allergy for my dog unless at least one of the conditions includes wheat, right? So that's a construct validity issue. Then there's the internal validity issue. The study is designed to infer causality. All right, so if we're doing a correlation design, then there's no internal validity because correlation does not imply causation. So if I do a correlation design, we don't call it an experimental design. Yeah. There's several ways to have a design that you could not conclude causality. For example, if you did not randomly assign participants, or if you did not control confounding variables. Basically, in general, it's the not controlling confounding variables. That's what we mean with internal validity. The next one, external validity. If what you find applies to the real world, then your study has external validity. And the last one, statistical validity, is following, honestly following the rules. No. It's like making sure that your statistical analysis agrees with or fits with and follows the rules, the requirements of the data that it analyzes. Every test requires some assumptions. For example, if I do a correlation study, and I'm correlating two continuous variables, but one of the continuous variables is not really continuous. Like it's group 1, group 2, group 3. And I'm trying to do a correlation between group number and happiness. That's not a correlation. If I try to do a correlation, like a Pearson's R correlation statistic, then I have violated the statistical assumption of that statistic, because that statistic requires 2 or more continuous variables. I can't say that group 1, 2, 3 is a continuous variable because these are not values, they are names. So don't confuse names and values, yeah? Group 3 doesn't mean there's 3 groups. It doesn't mean that it came third. It's just an arbitrary number. For example. So we have to follow the rules, the assumptions, the requirements of the statistical test. If we don't, if we pretend like we followed the rules, pretend like the data follows all of the assumptions and requirements, and we do the test, then we have made a mistake. And the validity of our results is wrong. It's bad. It's missing. Results are not valid if the statistical validity is wrong or missing. Okay, so those are the 4 types of validities. Any questions?
No?
All right. Participants in psychological studies tend to be psychology students. And psychology students tend to be young, educated, sociable, higher SES, which stands for socioeconomic status. They tend to be interested in the topic because they're psychology students and it's a psychology experiment or study. They tend to have greater need for approval, like because they look up to researchers or they look up to teachers. In other words, using undergraduate psychology students somewhat limits external validity. And if we turn back to external validity, it means the findings extend beyond the study to the real world. So if we only recruit psychology undergraduate students, we don't know if our results hold true in the real world. That's not to say that psychology students live in a fake world. They live in the real world also. But when I say in the real world, I mean in a more generalized world. Okay, I think we'll have a break now. It's a little early, but have a 10-minute break and we're gonna start again at 1:50.
Thank you.
Yeah. Okay, welcome back from the break. Okay. Standardization of experiments is very important. It's almost like almost part of the definition of experiment itself is standardization. So we need to control the procedure in order to control many variables. Everyone should do, see, say, think the same things as much as possible so that you can measure only the one thing that you want to measure, or you're measuring the influence of only one thing in multiple people. This maximizes your power to find the effect. And here's a side note, dictators also know that if you can make people do, see, say, and think the same thing, you have power over them. But that's a different kind of power in a different way. It's just an interesting side by side. So we need to create, when we're doing an experiment, we need to create a written protocol that all the collaborators know about. So everyone's on the same page and they can, and you need to fix and automate what the participants do from start to finish so that you eliminate all possible practice and order effects and the influence of them asking questions or something. So you don't want to allow participation to go unscripted, because when it's unscripted, things can happen that affect how performance affect performance. Okay, so we try to limit participant freedoms so that they do and say and think all the same things as one another, just like we need to immobilize a butterfly if we are studying its wings. We need to immobilize human variability to some extent while we study the aspect that we are interested in. You might be thinking, if we control the participation so much, wouldn't that limit the external validity? Because in the real world, people aren't required to all say, think, and do the same thing as each other. So doesn't the experiment limit external validity? Yes, it does. Experiments usually have limited external validity, some limit. Because in the real world, we do not and we cannot control people, control how they understand what they want to do, their freedom. Usually we cannot control them. Any questions? Expectancy effects. The placebo effect. Mainstream science does not yet comprehend the placebo effect. Scientists admit that it exists, but there is no good institutionalized answer for what it is, why it is, or how it is. So this placebo effect is this mysterious thing that tends to get in the way of our finely tuned and finely controlled experimental studies. Truth doesn't want to be put in a cage is one way to describe what's going on. Yeah. Scientists' observations affect their observations. We know this now from quantum physics, and we've already kind of known about it long before. It's almost common sense. We know that observations affect participants. We've known that for a long time. But our observations can affect more than just human participants. The scientists' expectations can come out through their actions in ways that they don't realize. The placebo violates a fundamental assumption of the scientific method because science says we only know by observing. But the placebo prescription is we know and then we observe, whereas science says we observe and then we know. So these two things, the placebo and science, run in opposition to one another. So we have two diametrically opposed concepts that play with each other in the process and activity that we call the scientific process or the scientific method. And I put a little yin-yang symbol to insinuate the play between placebo and science as two ways of knowing things. Kind of, yeah.
Has there been any studies that tested the extent that the placebo effect can, kind of like affect us?
Yes.
Yeah, because I read in the reading that we had where they did some kind of mock surgery where they didn't actually like cure anything, but then afterwards people still got better. So I'm like really surprised by it.
Exactly. That's a powerful example. In the assigned reading, you're talking about the reading that I said optional this week.
Mm-hmm.
Nice. All right. Yeah. Thanks for reading that. The study that you're referring to, half of the participants were given a mock surgery. They were actually cut open with knives, but nothing was done inside of them. So I don't know what the surgery was about, what they were, I think it was knee surgery, if I remember right, because
Yeah,
I've
it
heard
was
this
something
study.
about the knee.
Yeah, so half of the people needed surgery. Everyone needed surgery. Half of them got it, and some cartilage was taken out or some cartilage was put back in, something for their knee pain at the knee joint. And the finding from that study was there was no difference between the groups that got the real surgery and the mock surgery. which shows the power of the placebo at work in these people. It's especially powerful, I think, in that particular study because of how strongly people believed in the surgery. At least that's my opinion. That's just my opinion. You can think about it more on your own. But that's a very powerful example of the placebo effect. Shocking example. And the book describes why that was ethical. The reason it was ethical to give some people fake surgery, to actually cut their skin open and then stitch their skin back together, just to be a control subject, was because we needed to do exactly that level of damage to the control subjects in order to isolate the real positive effect of the surgery itself. And the surprising finding was that the surgery itself had no effect, or it had an effect equaled to the placebo effect. That's a better way to say it. In other words, the placebo was so strong that it matched the real effect of surgery. So the question of, has the placebo been measured? Can it be measured, and how strong is it? No, it can't, because in my opinion, the placebo is only as strong as the belief in the treatment. If you have, yeah, that's what I think. And it's just a really fascinating topic because this is like, I'm so interested in this that this is almost more interesting to me than psychology. It's really interesting. Manipulation check. But first, let me qualify what I said. I obviously am interested in psychology. This is why I got my degree and why I'm teaching it and stuff. Psychology is extremely important. Don't get me wrong. Manipulation check. So you need to check to make sure that if you manipulate the participant's belief, you have to check that they really believe it. If you manipulate their mood, you need to check that you've really manipulated it. If you deceive them, you need to check that you really have deceived them. But you don't always have to check that you successfully instated the treatment. You only need to check when it's not obvious, when there's any doubt. If you have any doubt, or if the readers would have any doubt, then you need to check. So, for example, if I want to test the effect of sadness and depression on reaction time, I need to make sure that when I assign participants to the sadness condition, and I try to make them sad somehow by showing them a sad movie, I need to check that they are actually sad, because it's possible that they watched the sad movie and it did not affect their mood. So whatever your manipulation, if you have any doubt that it actually moved people into that condition, into that frame of mind, then you need to check. Check by asking a question after the study is done. Say, on a scale of 1 to 10, how's your mood? If you find that people in the sadness condition are not different than the people in the control condition, then you have done your manipulation check and also invalidated your study. So you need to check to confirm that it worked, that your manipulation worked. Any questions? Again, the manipulation check is only for some studies, not all studies. Just the ones where you have some doubt or questions about whether the manipulation was successful or not. Pilot testing is something that I have underestimated in my own research. It's important. It's really important. It's easy to forget or downplay and think that pilot testing is just an extra step, and you're in a hurry, so you don't need to do that step. You can skip it. I have been in that situation more than once, and it has ended not well for me. So I need to learn this just as much as you do. Pilot testing is important. Even when you think you have everything perfect, you don't know what's wrong because we are blind to the things that we cannot see yet. We're blind to, I mean, if we are the researcher, we're kind of blind to what it's like to be a participant. We have to either be a participant or demonstrate it on participants before we know that everything is right. So the pilot testing is to confirm and to fix and to iron out problems. All right, now to an exercise for you. Decide whether these could be studied using experimental research. Why or why not? First one, the effect of parietal lobe damage on people's ability to do basic arithmetic. Would you want to study this using experimental research? Yes or no? Why or why not? You can answer in the chat box or you can answer out loud.
I mean, I remember from cognitive psychology, they've made a way to dampen certain parts of the brain, and I'm sure they did something like that. They did like dampen the parietal lobe in
Good.
order to simulate damage, and I think they. So yes, you can do that without physically hurting someone,
Yes, you can. That's right.
or you can find people who have their parietal lobe damaged, and for this experiment as well. You don't have to like
Good.
go around putting holes into people's heads.
Yeah, and then you can just have the control group of normal people with no damage to their parietal lobe,
Yeah.
and then
Yeah.
compare the difference.
So you can either use technology to simulate the damaged parietal lobe, or you can find people who already have a damaged parietal lobe.
Very
Again,
good.
we're not forcing anyone to do this. It's volunteer.
Very good. Good answer. And your answer definitely went straight into the ethics of damaging people. So very good answers, both of you. All right. Number 2, effect of being clinically depressed on the number of close friendships people have.
I hope I don't think this would be for a research experiment. I don't think we can um make a research experiment for this. It doesn't sound like something we can do. We can't just simulate someone being clinically depressed and ruin a relationship. So I don't think. I think it's. I forgot what's another one. Diane, do you know like the correlation? Like
And also, I think for number 2, it'll be hard to make a construct about exactly, like, how would you specify exactly what close
yeah,
friendships mean, and how would you test it out and experimentally,
it's kind of vague. It's more
yeah,
like a curious
Good
question
critique.
thing to do.
it seems too vague.
You're right. That's a good critique on this number 2. I didn't define close friendships or even imply how to measure or yeah. So you're right. That's a good critique. And you're right that it's not ethical to study this in an experimental way. So you're right. We would not use an experiment for number 2. Number 3, the effect of group training on social skills of teenagers with Asperger's syndrome.
I mean, yeah, that seems simple enough for an experimental research. Yeah, I think that's possible to do that. Simply
Okay.
just train a group of teenagers that do have Asperger's syndrome, and then put them with a control group who don't, and see if there's any difference.
And
in their-
afterwards, if it works and there's good benefits, we can offer the same group training to the control too.
Mm,
It
yeah,
wouldn't be ethical. No, there wouldn't be any ethical issues, I mean.
yeah. There's nothing wrong with this. There's nothing wrong ethical wise.
You're right. And the control group would be who?
Teenagers
Yeah,
that
with
don't have
Asperger's
Asperger's.
syndromes too, right?
The perfect control group would have Asperger's syndrome also.
Yeah.
We won't be giving them the same training. Okay, I understand. Yeah.
Yeah, very
Yes.
good. Good answer. And you're right. If the treatment works based on the results, then we could offer that treatment to the control group. Then that's ethical. Yeah, very good. Good thinking. You guys are getting it. Number 4, the effect of paying people to take an IQ test on their performance on that test.
Yeah, that seems fine to do that.
Mhm.
If you have volunteers and we'll say we'll give them money to take their IQ test. Let me just chart how well they do and compare it to the control of people who aren't giving any money to take their IQ test.
Right. Yes.
Okay.
We would need to have a represent like a um, it would be a little difficult to establish that the control group had equal intelligence.
That's a problem.
So that is hard. But it
Maybe
seems
we can do it with the same person. Perhaps the first time we do it without giving them incentive to do it. Incentive. Then we make sure they don't study or don't do anything different. The next time they do the IQ test, we give them the money incentive and see if anything has changed.
very
Yeah.
good.
I also
That work?
wonder if there's gonna be a difference between if you, while recruiting them, you tell them beforehand that you will pay them for an IQ test, and another situation where you bring everyone in and then you just randomly assign certain people to receive money and then they only find out that day. Would there be a difference in their
That's a
IQ?
good way to do it. Yeah. So the issue is whether we can separate the effect of payment from the effect of natural intelligence. And I don't know if, so the within subject design is nice. Yeah. Probably I would use a within subjects design for this one, like you were suggesting. Good. All right. Yeah. Good answers. Next. Choose a between subjects or within subjects and say why. Oh, is this more of the same? Whoops. Sorry, hold on. Okay, so this one is whether it would be an experiment or not. Ah, I skipped a slide here. Okay. An experiment shows that participants who receive psychodynamic therapy for dog phobia improve more than participants in a no treatment control group. So the dog phobia therapy and the no therapy. Identify possible problems with this research design and how to correct them. Let's do this as a class. So you tell me what to type and I will type it. What are some problems? And how do we fix them? So one group receives therapy for their dog phobia. Others have dog phobia, but they don't get treatment. They're in a control group. Tell me what possible problems could happen if the experimenter or researcher doesn't do things right, if they don't know what they're doing. What could go wrong?
What about the individual effects on the intensity of dog phobia?
Very
Could
good.
affect because everyone might have dog phobia, but the intensity of it might be different.
Very good. That means that it's possible that the really intense phobias happened to be in the treatment group,
Yeah.
and the less intense ones in the control group. That would be a problem. You're right. How could we correct it? Any idea? Suggestions?
Perhaps
Can we let them do like the survey first?
Very
Like rate the
good.
students.
Correction. Survey first. Assign in a balanced fashion. One way to do it, and the book describes this, is you take the top two scores on the survey and split them up into their different groups, one in the treatment, one in the control. Then you take the next two highest scores and do the same thing, and on through until you have a pretty evenly balanced treatment and control group. So that's a good solution. Very good. Any other possible problems with this study? Or something that could go wrong?
How are they testing to see whether the dog phobia improved? Are they just doing a survey before and after? Are they doing a simulation, or are they actually presented with a dog? Because I think depending on how they tested for the improvement, it makes it different. Because also, I think we studied a study once about people who were scared of flying, and when they tested it in a simulation, it improved. But then later on, when they tested it on real flying airplanes, it like they found out that actually it didn't really improve.
Very good. We need to ensure that the test is valid with external validity. So I'm going to put that as a problem here. Test validity. And when I say validity, that includes external validity. You're right. And the obvious correction is to use a valid test. So if the test suggests that people got over their dog phobia, but then in the real world, they still have a dog phobia, then the test is not valid. So we need to use a valid test, change it to a valid one. Good. All right. Just an exercise just for getting you thinking. Did you have any other problems with this? Like, did you think of any problems? Any others? If not, we can go on. All right, choose between a within subjects or between subjects design for each of these and tell why you would choose that one. All right, so first one, you want to test the relative effectiveness of 2 training programs for running a marathon.
I think for this one, the between subjects might be better because if one of the testing works and then we ask the participants to train in another test, then if it worked, they're already faster. So bounding variables, because maybe from when they were at the start and they got better, they might not be able to get even more better as easily.
Good. So you would use a between subjects design.
Yep.
Very good. I could also point out that running the marathon itself does a lot of wear and tear on the body. It puts the body in a weakened state that needs some recovery. So, I mean, well, actually, that's not a problem. Never mind. But yeah, for the reason that you said. But it could also be done within subjects if you gave enough time between training programs, and if the training program could be forgotten or not. But if the training program is so good that it's really incorporated into the runner's style, then it would have to be a between subjects, because you can't forget or unlearn something in order to learn a different thing so easily. It can be difficult to forget things. So that's why a between subjects would be good. Yeah. Number 2, using photographs of people as stimuli, you want to see if smiling people are perceived as more intelligent than people who are not smiling.
I think for this one, a within subjects might be better because there might be individual differences in what a person thinks about smiling, not smiling, and intelligence. So testing them twice would be better, in my opinion. But I
Testing
might,
them twice, you mean within subjects?
yeah. Anyone else have a different answer or another reason?
Yeah, anyone else?
And I just agree with Diane about like the within subject design.
Could you say that again?
I'll just say like I agree with her like about the within subjects design.
Right. Yes. Me too. This is simple enough I mean, it's possible to run it within subjects. And I think we all kind of decided from the beginning of the lecture that if we can do within subjects, that's the way to go. So this one we could do within subjects. Number 3, in a field experiment, you want to see if the way a panhandler is dressed affects whether or not passersby give him any money.
Can we actually control how who the participants are because this is a field experiment?
Right. The panhandlers would be Confederates. They would be people who are actors. So in this field experiment, you have the experimenter who's maybe watching very quietly and secretly, and you have an actor acting like a homeless person, asking people for money, and they could be dressed neatly or sloppily.
I would say like between subjects.
Why?
Because like from like the last semester we learned about like the continuity. Maybe the feeling of the first time they help someone, so the next time it could be like bias and errors happens because they feel like okay, like first time I helped someone, so the second time I would love to help someone too.
Mm-hmm. Yes. There's the effect of helping someone that influences whether you're going to help someone again the second time. Whether you help the second homeless person depends on whether you helped the first person or not. We don't know how it helps or how it affects, maybe helping someone the first time makes you less likely to help the second time, or maybe it makes you more likely to help in the second time. I don't know, but there could very well be some influence of the first condition on the second condition.
Because of the social psychology, like last time we studied about like the continuity, like about like for like example like asking like someone asking for like a small favor, and we did it, and the second time we did it too because of the continuity. So I think maybe it could apply.
I see. So you're suggesting that the first giving would increase the chance of second giving.
Yes.
I see. Interesting. And good job to apply a social psychology concept of continuancy. What is it?
Yeah, like continuance. Is
Yeah.
it?
Yeah, good job. You should all be ready, willing, and quick to draw connections between classes. So good job. Psychology is one discipline, it's not many. You want to see if concrete nouns are recalled better than abstract nouns.
I think within is better because some people might be better at recalling than others.
So would you do within or between for this one? Some people said within. Mudme said. Within or between, and why? Can you hear me?
Yes, like
Yeah.
we're
Hear you
still
now.
thinking about like the cost.
I think for a second we couldn't hear you, but now it's okay.
Right. My internet signal fluctuated. So your answer for number 4, anyone?
Within.
Yeah, within. There is an effect of recalling one kind of word on recalling another kind of word. So if you mix abstract and concrete together in a list, and then you ask people to recall the whole list, they're going to tend to recall the concrete ones and forget the abstract ones. But if you can give them all concrete words and ask them to recall all the concrete words, and then give them all abstract words and ask them to recall all of them, then that's that's a good way. So you could do this within subjects. Good. Okay, your last task for today is to meet with your group members. I want you to share your article that you would have supposedly written a summary already by today. If you haven't already read and written a summary of an article, you need to do that as soon as possible. But for today, I would like you to share your article with your group members, telling about what you read, telling about the article in your own words from memory. I don't want you to read the article to people. I don't want you to read what you summarized to people. I just want you to speak from your understanding. And it's okay if you're wrong. If you misunderstood it, it's okay. But try to share with others what you read, so that what you learned, other members in your group can also learn. Ask clarifying questions of one another so that every member understands the basic idea of each article. Your paper represents your shared knowledge. And I will say this to clarify that every group has at least 3 members. I've checked all the groups now. It looks like groups have between 3 and 6 members. I haven't seen any more than 6 or less than 3. Your articles for your paper's introduction section requires 3 sources. Since you are at least 3 people, you will do 3 sources. If you're a group of 3, you're going to do 3 sources. If you're a group of 4, you do 4 sources, 5, 5, 6, 6. So every member of the group does 1 article, summarizes it, and that forms part of the introduction section of your final paper. Are you clear on that, everyone?
Yep.
All right.
Mhm.
So now it's just a chance.
Just one question.
Yeah.
One question. So we have to trim down our article summaries to just a single paragraph. Is there a specific part of the article that you want us to focus on, like what they tested on, or maybe the results?
Thank you. Very good. Yes. Because last week I told you to make we could call it a structured summary, where you summarize a bit of every single section of the paper. Whereas now I'm telling you something different. Slightly different. Now I'm saying pick and choose which information you really need to say and which information you don't really need to say. for the parts of the article that you summarize, sorry, for your summary, part of it is going to be relevant to what you're studying, it's relevant for readers so that they can read and understand the important studies that came before your study.
Okay.
And what makes those studies important for your study is different for each article. Some articles, their method section is very important to your study. And some articles, their results are very important for your study. The most important thing about their study was their hypothesis, their question, or their theory. So you might not care about their method and results, but their theory is very important to your study because you're using the same theory. In that case, focus on the theory part and delete the details about everything else, so that your final paragraph, which used to be a page or a longer paragraph, it condenses to a shorter paragraph that is what is most relevant for your research question. You might not know what's relevant and what's not relevant because you haven't designed the study yet. That's okay. Just if you don't know it's important or you don't know that it's not important, then keep it. Keep it just in case. Just delete and limit the details that are less important. And this is teaching you an important skill of the revision process. It's a good skill to develop that you write more first and subtract second. Write too much at first and then delete some of that second. You can see what to delete better after you've written it. This is my opinion. This is my suggestion. Take it or leave it. Here I have told you also to choose someone from your group to write the introduction paragraph and choose another person to write a summary paragraph at the end of your introduction section. Right now, if you have the Google document with summaries on it, basically this is the introduction section of your paper. This is the start. Then there's going to be the method, the results, the discussion. We're not there yet. For this part of your paper, the only part that we've talked about so far, choose someone to write the first paragraph and another person to write the last paragraph. And every single one of you is going to write an in-between paragraph, a paragraph that comes between the first and last paragraphs of the introduction section. So if there's 3 people in your group, there would be 5 paragraphs making up the intro. So it's the intro of the intro. Then summary 1, 2, 3 of your articles. Then concluding paragraph. If there's 7 people in your group, there's going to be 9 paragraphs. 9 paragraphs. So if there's 5 people in your group, there's going to be 7 paragraphs. Any questions? I
Wait,
think
I have a question about the last paragraph. So for the summary paragraph, it'll be the last paragraph of our intro, and it should basically summarize our research question plus the 3 articles we read. Or is it just going to summarize what we're trying to find? Or do we also have to add on our 3 different articles?
I think what you said the first time is right. Summarize, basically give a short recap on the studies that have been summarized up to that point. But it should be a very short, very brief, like 2 or 3 sentences to summarize all of what came before. And what you said is right. It should have the research question. That's most important. So whoever writes that summary paragraph needs to make sure that that research question is very clear in that paragraph. Also, whoever writes the intro paragraph should also be clear on what the research question is without saying it, just introducing. So don't say what your research question is in the very first paragraph. Don't. But allude to it by introducing the area, the topic, the importance of this particular area of research. Any questions further? Further questions?
Do we have to submit our summary to you or just keep to ourselves?
Keep it to yourselves.
Okay.
Thanks. I will read it all eventually, but I don't have the energy to evaluate all of them at this time. But I promise you I will give you feedback. You will have feedback about what you've done. Okay. Okay, so yeah, that's that. Any further questions?
We'll have to continue to read the assigned reading this week, right?
Yes, you're right. The assigned reading listed in the syllabus next to class 4, because we are in the 4th class. The reading that I assign, like for example, if I give a quiz next week, you're responsible for the reading that is assigned for this week. That's what the quiz would test you on. And that topic material that you're reading for this week is what I will lecture about next week. So you're reading ahead by 1 week or a few days. Any other questions? Okay. Don't be too stressed or concerned or worried about what you're writing or how you're writing at this stage. Don't be too self-critical, but do learn from one another. If what you wrote is, you think it's okay, and then you see someone else wrote something more high quality, then if you can, revise your own writing and make it higher quality like theirs, so that you are learning from each other. Read what one another writes and pick up clues from what I'm teaching about how to write. And it'll all come together. It's like learning anything. Learning how to write a research paper is like learning how to do anything else. It just, you learn it by practicing and getting feedback and watching other people do it. And then it just sort of comes. All right. Any other questions? Okay, so now for the rest of the class, I cannot divide you into groups in the classroom. So I suggest, how can we get you all together?
Professor Jason, if my group, we already have a line chat room and then we can just call and video call each other from there, then can we leave the class now and do it there?
Perfect. And that's such a good idea. Please,
Do we-
everyone, create your own line groups.
Do we have to come back after like 15 minutes or something, or is the class done?
The class is done. The class is done now. This assignment is kind of your homework, or it's however much time you, or however much or little time you want to spend on this with your groups is up to you.
Okay, thank you.
You're welcome. All right, so I think that's the end of class now. Just make sure you get with your groups to discuss who's doing what. All right, thank you guys for coming to class today and asking all your great questions and participating. Bye-bye.
Thank you.
Thank you.